Oh, hi there, team. Just a reminder that when you're doing the inverses, you just switch x and y. That's all an inverse is. It takes your inputs and makes them outputs. It takes your outputs and makes them inputs. So let's imagine a function that says, if you tell me how many hours you work, I'll tell you how much money you make. Okay. But what if I flip that function and you tell me how much money you made, and then I could tell you how many hours you worked? Okay. That's what an inverse is it does the opposite of what a function does. So many of you are dealing very well with this when we have a table. With a table, you just swap all your values. Okay, that's it. You just flip x and y. With a graph, it's a little trickier, where if you have a parabola like that, you would reflect it through the line y equals x. That's a little weird. These things reflect through y equals x when they do that. It's kind of a cool visual trick. But then algebraically is where we actually, if we had more time and this wasn't summer school, my goodness, I would be making you do so many examples like this to build your algebraic muscles. But let me just show you a couple. Some of you have some problems with this with your inverse operations. And everyone can take a look at what this is like. All right, so my first step when I'm doing algebraically finding the equation for the inverse is I'm going to write this in y equals x, some kind of function of x form. So I'm just going to write it as y instead of f of x. And then I'm going to change pens and indicate to my reader that now I'm finding the inverse. Okay, this is not an exponent. You don't raise things to the power -1 in this case. It's a notation that says the inverse of f of x. Okay, and so now all I do is I swap the position of x and y. And if I throw this line into Desmos, it will graph the inverse. Let me show you. I have it in Desmos already. There it is. There's my line -3x plus 8. So y-intercept is up there. And if I wanted to reflect that through the line x equals y or y equals x, let's find out what happens if I copy this, boop, and just change this to a y and this to an x. Boop. Okay, it worked. Cool. So it reflected it through the line y equals x. See that? Isn't that super cool? All right, it is super cool. I think it's cool. Maybe you don't think it's cool, but I don't know what the kids think is cool these days. I think that's cool. But we're not done because we want to express this as f inverse of x. So we need to solve for y. So let's go ahead and do that algebraically. First thing I'm going to do is I say I want to isolate y. That's my goal. So I'm going to subtract 8 from both sides. That will cancel these two because 8 minus 8 is 0. And so now I have the equation x minus 8 is equal to -3y. Cool. Y has one less dance partner. Now, one more inverse operation. I don't want to multiply y by -3. I'd just like to know what y is on its own. So I divide the whole side of the other equation, the whole side of both equations by -3. And so then that will give me this final line here, -x minus 8 over 3, because negative denominators make me want to barf in a bucket. So don't make me barf in a bucket, please. Just write your negatives on top in the numerator. Just have that as a habit, okay? It's a good math habit. All right. And then we can even distribute that negative in if we want to be super fancy. So if I distribute that in, that would be -x plus 8 over 3 is equal to f inverse of x. That's equal to y is equal to f inverse of x. But I don't want to write is equal to y. I just want to write the inverse. So that would be the inverse in that case. Okay. Now, we didn't get a chance to do many challenging quadratic examples together. But if you want to work your algebraic muscles, then this is what you can do. You can create a quadratic. Quadratics, remember, they're of the form y or f of x, g of x, whatever, is equal to ax squared plus bx plus c. Put in values for a, b, and c, and then see if you can find the inverse of that function. It's a good algebraic workout. Here's how you do it. One thing I don't want to do at this point is go ahead and write this as y equals and then swap the position of x and y. because my x is in two places right now. Uh-oh. So how would we deal with that if we wanted to deal with that? And I want to deal with that. I want to deal with challenging things and do it correctly. So what I would do is actually isolate my x first, get x in one place. And we can do that by completing the square. So here, first I'm going to factor out that 2. So it's going to be 2 times x squared minus 4x. I'm going to leave some space in that bracket to add 0. And then that's plus 3. Okay? Follow me so far? Notice that, and the way to check your work here is to go backwards with the distributive property. That would be 2x squared, and that would be minus 8x. But I don't want I want to do that. And then I need to create a perfect square trinomial here. So what I do is take this number, minus 4, and some rough paper, you divide it by 2, and square the result. That would be minus 2 squared. That would be 4. So what I'm going to do is add 4. But if I add 4, I better subtract 4. Notice I've added 0. But now the thing that I have underlined there is a perfect square trinomial. So this will be equal to, here we go, y is equal to 2 multiplied by something in brackets. What's in brackets? Well, let's figure it out. I'm going to blow your mind here, maybe. This is x minus 2. There's where the minus 2 comes from. Squared. Okay. And then this 2 is going to multiply that minus 4. That minus 4 still has to come outside the bracket. So it's going to be minus 8 plus 3. That plus 3 can come down. All right. Now, you might be saying, whoa, 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 hold on. Where did that minus 2 come from? Where did the minus 4x go? And all of these things. All right. Let's take a look at this part of the expression. All right. We'll do that over here. X minus 2 squared is equal to x minus 2 times x minus 2. Okay, I hope you agree. And then this is equal to x squared minus 2x minus 2x plus 4. Let's simplify that. X squared minus 4x plus 4. Oh, wait, wasn't that what you underlined right there? Yes, it is. Okay, that's why I completed the square so that I could get x in one place only before I switch the position of x and y. That way I don't have to solve for y, but y is in multiple places at once. That makes it hard, right? Okay, so yeah, so that's why that all happened. And when we wrote this x squared minus 4x plus 4 as x minus 2 squared, we still hadn't dealt with this minus 4 over there. So that's why I had to take it out of the brackets and multiply it by 8. So I multiply it by 2 to make 8. Oh man, I'm making a mess of this now. This is minus 4x plus 4 minus 4. Ouch. Okay, and that's x minus 2 squared. Good. Let's get rid of some of my arrows. I tend to draw too many arrows as I'm talking, trying to show this came from here and that came from there. All right, because we're not done. You want to see me bring this across the finish line, right? So that you know how to bring these across the finish line. Last step is just tidy up your algebra. This is y is equal to 2 multiplied by x minus 2 squared minus, that is minus 5. Okay, let's take a look at it in Desmos and see if that's indeed what we have. We're not going to look at that and that, but we're going to look at this. Oh, yeah, it is. Look, there's the vertex there. You see? 2 minus 5. So that's correct. Like I just changed the form to vertex form. All right, now let's go for it. Okay, now we swap the position of x and y. I would change my pen or do something to my reader to say this is a new function. Like I'm now finding f inverse of x. When I write this as x is equal to 2 multiplied by y minus 2 squared minus 5. Okay, and then again, if we were in class together, hooey, you would get some algebra workouts with this because you would say, I want to isolate y, but y is beneath several layers of defense. The first layer of defense we can peel away is adding 5 to both sides. So then we get x plus 5 equals 2 multiplied by y minus 2 squared. Okay. And then we'd say, well, now we're going to divide both sides of the equation by 2. Okay, good, done that. So this cancels that. So then we get x plus 5 over 2 is equal to y minus 2 squared. And then you'd say, well, now this is a big inverse operation that we're going to do. We're going to take the square root of both sides, the entire side. So that should cover the whole fraction, not just the top. And then this is plus minus because I don't want to explain everything. I just want to do it. Okay, so this just you negative square to positives. So we need some way to reflect that in our inverse operation, and so we use the plus minus there. Okay, so let's go back to blue. All right, so now we have this beautiful thing, which is equal to y minus 2, because we effectively, this cancels this. Right? And then we have over here plus or minus the square root of x plus 5 over 2. And the last thing we're going to do is add 2 to both sides. There, 2 plus or minus that. Now we'll do it. This is the inverse of that function. So I might finish off by writing it this way. F inverse of x is equal to plus or minus the square root of x plus 5 divided by 2 plus 2. Okay. And that, let's put it into Desmos. See if we're right. Notice I check my answer in Desmos. I just have this habit of throw it into Desmos. It's a very good idea. So we're just going to graph it as f of x is equal to the square root of, what was it, x plus 5 over, no, but we want that bracket over, the whole thing over 2. Okay, plus 2, like that. That looks good as the top half, doesn't it? And then we're going to copy that and just do our plus minus this way in Desmos. Boom! Oh, look at that. It intersects at the points where it crosses the line y equals x. That shouldn't surprise us because those points reflect to themselves like they are their own inverses. And what else? Right, the vertex went from there. Sorry, went from here to here. So you can see the x's and y's have been swapped and everything else just looks beautiful. So that's how you do these algebraically when you have time in class and lots of time to practice. So build those algebra muscles and try a few examples yourself. I did an example where the square completed fairly easily, but you can try harder ones if you want. Okay, that's it for me. Thanks for now. Bye for now, everyone.